We're going to be talking about perpendicular and angle bisectors. And oh, by the way, next week, I put this as an assignment in Canvas. You need tools. You need compass, protractor. I would do a compass, a protractor, and a ruler would be your best bet. You don't technically have to have a ruler because you can do everything with a compass and a protractor, compass and a straight edge. But there's one that's really easy if you have a ruler. So, and if your protractor has a ruler on it, that should be just fine. So we're going to be doing constructions. You have options for which tools you use, but I would just bring them all, and then you can decide that day which ones you actually want to do. Because some of you are going to want to do it one way, and some of you are going to want to do it another way. Okay, 5-2. Perpendicular and angle bisectors. So those are a couple of the things you're going to be constructing, which you guys already know how to do. So it's fantastic, right? So if you look at this picture here, it says triangle ADC. Oh, D, not D. Oh, I changed it. Call this a D. Sorry. Call that D. Triangle ADC is congruent to triangle BDC by what? Not HL. SAS. We know this is congruent, right? So side, angle, side is what we're looking at. So those two triangles are congruent by SAS. Okay? Notice that is a perpendicular bisector, right? CD is a perpendicular bisector. Okay? When we have a perpendicular bisector like that and we turn it into triangles, if the triangles are congruent by SAS, then how do I know that AC is congruent to BC? CPCTC, right? CPCTC. So what we're talking about today involves that scenario. When you have a perpendicular bisector, like we do here, then what it says is if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So basically what they're saying is a point anywhere on this line, anywhere on the pink line, okay? I could pick a point right here. I could pick a point up here. Doesn't matter where I put my point. If it's on the perpendicular bisector, then this length will be the same as that length. And this length will be the same as that length. Equidistant. EQUI and then distant. Okay, so if a point is on the perpendicular bisector, it's the same distance to your endpoints of the segment. Does that make sense? The converse is also true. The converse says if a point is equidistant from the endpoints, then the point is on the perpendicular bisector. Okay? It's working. Is that what you're here for?
Yeah.
I'm telling you, you what?
I want to see what that is.
Oh, it's not.
Stinky and stuffy. Is it stinky and stuffy in here?
No, because it's working now. I'm telling you, I will push the arrow down. We should pause this, huh? Okay. Let's try again. So here's the beauty of this lesson today, you guys. If you're like, I don't remember what to do, set things equal to each other. Every time, set them equal to each other, because I promise you that's what's going to work. Because here's the deal. If you're given this setup, so look at this first picture. They give us that this is perpendicular and these are congruent, which means this is a perpendicular bisector. Right? That's our perpendicular bisector. If you have a perpendicular bisector, then the distance to the endpoints is the same, meaning this is congruent to that. So all you have to do to find x is say x plus 6 equals 2x, take away the x, and you get x equals 6. Okay? So if x is 6, what is EF? 12. 2 times 6 right? 2x is your EF. 2 times 6 is 12. Look at letter B. It says find x. Notice this is perpendicular. These are congruent, meaning this is a perpendicular bisector. The distance to the endpoints anywhere on that perpendicular bisector has to be the same. So that means that RT has to be congruent to ST. So how do you solve for x? You said, go ahead.
10x minus 3 is equal to 5x plus 2.
Set them equal. 10x minus 3 equals 5x plus 2, and solve it. So take away the 5x, add the 3. So 5x equals 5, divide by 5, and x is 1. Okay, so what is RT? 10 times 1 minus 3, right? You just take the length of RT and you plug in your x value. So 10 minus 3 is 7. Look at the next one. Slightly different because they didn't mark them congruent, but they told us they're congruent, right? They gave you a 3 and a 3, and they told you this is perpendicular, which means this is a perpendicular bisector. So the distance to the endpoints, this length here and this length here, has to be the same. So what do you do? How do you solve for x? Set them equal. You're going to say 2x minus 3 equals x plus 2. So take away the x and add the 3. So x is 5. And GH is what? 7. 5 plus 2 is 7. Está bien? Okay. That is perpendicular bisectors. Okay? Angle bisectors are not all that different. They're going to look different, but it's the same idea. The angle bisector theorem says this. If a point is on the bisector of an angle, then the point is, any guesses? Equidistant from the sides of the angle. Okay, so last time it was a perpendicular bisector. Now it's an angle bisector. Look at this picture. This AD right here has congruent angles there, okay? Meaning AD is an angle bisector. Do you see that? Because these are marked congruent, AD is an angle bisector. What it says is if there's a point on the angle bisector, like for instance, point D right here, the distance to the angle has to be the same. So what they're saying is BD has to be congruent to DC. Okay, the one thing to watch out for here is these are going to be the perpendicular distance. Whenever we talk about the distance from a point to a segment, we go perpendicular because you can't go, oh, well, this one then has to be the same as this one. There's no consistency there, okay? It has to be the perpendicular to the side that we're measuring. So make it perpendicular, but it will be congruent. Okay, so converse says, if a point is equidistant from the sides of an angle, then it is on the angle bisector. Okay. All right, 4 problems, and then we're done. Let's think about this. It says find the indicated measure. So for this one, they want you to find BD, okay? They want you to find this length. What do you notice? Yeah. You have an angle bisector. These are marked congruent. So AD, right, this right here is an angle bisector. Okay, if that's an angle bisector, then what is true? BD has to be congruent to DC. Okay, so what we're going to do is we're going to set those equal. We're going to say 3x plus 1 equals 5x minus 1. So to solve that, we're going to ditch this x equals right here. Take away 3x, and you get 2x. Add 1, you get 2. So if 2x equals 2, then x is 1. So we get x equals 1 for this problem. What is BD? It's 4, yeah. Plug it in. 3 times 1 plus 1 is 4. So BD has a length of 4. Questions on that? All right, look at this next one. They're asking, what is the length of DC? What do you think? Julie? Anyone know? What's DC? It's 5, right? This angle is congruent to that angle, so AD is an angle bisector, right? And when you have a point on an angle bisector, like point D, it has to be the same distance to B as it is to C. So this would be 5, so DC is 5. Look at the next one. This one's a little different because now they're telling us this is basically using the converse, right? If these distances are congruent, then what is true? The other angle's 20 degrees also. It's an angle bisector, right? If those are congruent, this is an angle bisector. And if that's an angle bisector, if this is 20, this has to be 20. So CAB is how big?
20 degrees.
Not 20.
40.
40 degrees, right? CAB goes from C to A to B. So you want the whole thing together. So CAB is 40 degrees. Questions on that? Last one. Then you guys are going to have a lot of time to work, which is good because you have 2 lessons to do. Example 3 here. Look at what they give you. You have a perpendicular with a length of 5 and a perpendicular with a length of 5, which means this is what? A bisector. This is an angle bisector if the distance to them is the same. So if that's an angle bisector, how do you find x? Set them equal. Yep, these will have to be congruent angles. So you say 4x equals 2x plus 20. Take away that 2x and divide by 2. So x is 10. Okay, so what is the measure of each of those angles? 40. Yeah, they'll both be 40, right? Because we know they have to be congruent. So 4 times 10 is 40 degrees. So this one is 40 degrees and this one is 40 degrees. And you can always plug it in to check. 2 times 10 is 20 plus 20 is 40. So it works out. Okay. Questions on that? 5-1 and 5-2. That's it.